Okay, so today we're going to look at 2.7 inverse functions. So the definition of the inverse of a function, let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. So what that means is just if we plug in a function into a function, and when we simplify, we get just x. That means that they are inverse functions. And we denote that by f to the negative first power, okay, which just is read f inverse. Okay. The other key thing to make sure you know is the domain of f is equal to the range of the f inverse and vice versa. So they will just swap, which will be nice when we look at something a little bit later. So the way we verify if two functions are inverses of each other is we plug them into each other. So the first thing we're going to check is we're going to find f of g of x. Okay, with this, we did this with compositions. So if we plug in, we would have f of x minus 2 divided by 3. So if we plug in x minus 2 divided by 3 into our function of f, we get 3 times the quantity x minus 2 divided by 3 plus 2. Well, 3 divided by 3 cancels. We're left with x minus 2 plus 2. Negative 2 plus 2 cancels, and we're just left with x. So that checks. So now let's go the other direction. So second thing we want to check, g of f of x. So we're going to find g of 3x plus 2, which is going to be 3x plus 2 minus 2 divided by 3. So 2 minus 2 cancels, and we're left with 3x divided by 3. Well, our 3's cancel, and we're just left with x. So that checks. So now we can say f of x and g of x are inverses, or inverse functions. Okay. All right, so now we're going to go through the steps of finding the inverse of a function. So the first thing we're going to do is change f of x to y. Change f of x to y. So we're going to go through this first example as we go through these steps. So I'm going to change f of x to be y equals 7x minus 5. So that was our first step. Now, for our second step, we're going to switch x and y. So this is going to become x equals 7y minus 5. Now we're going to solve, let's see here, for y. So if we want to get y by itself, we're going to need to add 5 to both sides. So x plus 5 equals 7y. And to get y by itself, divide by 7. So y equals x plus 5 divided by 7. And then our last step is we're going to change y to f inverse of x. So step 4, we have f inverse function of x equals the x plus 5 divided by 7 that we previously found. And that's how you find the inverse of a function. Okay. All right. So now let's try b. So start off, we have f of x equals x plus 2 divided by x minus 3. So first we're going to change f of x to y. we're going to switch our x and y values. So x equals y plus 2 divided by y minus 3. And now we want to solve for y. So this one is going to take a little bit more work. We want to start off with getting rid of our fractions. So I'm going to multiply both sides by the quantity of y minus 3. So we're left with x times the quantity y minus 3 equals y plus 2. We're going to distribute. So xy minus 3x equals y plus 2. So to solve for y, we know we need to get the values or the terms that have y in it to the same side. So I'm going to add the 3x to the other side. I'm going to subtract the y to the left. Okay, so our 3x's cancel and our y's cancel. So we have xy minus y equals 3x plus 2. Okay, so since we have two terms with y in them, that's something that they have in common. So I'm going to factor it out. Then to get y by itself, we're going to divide by x minus 1. So y equals 3x plus 2 divided by x minus 1. Okay. So lastly, we're going to change y to f inverse function of x equals 3x plus 2 divided by x minus 1. Okay. And here we know x cannot equal 1 because that would make our denominator 0. All right, now let's look at C. We have f of x equals x cubed plus 1. So going through our steps, change f of x to y. So y equals x cubed plus 1. Change x and y. And then solve. So we're going to subtract 1 on both sides. X minus 1 equals y cubed. Then to get y by itself, we're going to cube root both sides. So y equals the cubed root of x minus 1. So our inverse function is the cubed root of x minus 1. Okay, so we talked about this a little bit when we were looking at our cube and cube root functions. Okay, I said that there was some type of symmetry with them, and the symmetry that we have is across the line y equals x because they are inverse functions, which we just saw with this problem. Okay. All right, so horizontal line test and one-to-one functions. So what happens when you try to find the inverse of the quadratic function f of x equals x squared? So let's try it. So y equals x squared. Switch x and y. And then to get y by itself, we're going to square root both sides. But remember, when we take the square root, we have to put plus or minus in front. So y equals plus or minus the square root of x. Well, that's a problem because that's not a function. Because of that plus or minus. Okay. So because of that fact, that helps us with the horizontal line test for inverse functions. So a function has an inverse if it passes the horizontal line test. Okay. So vertical line test told us it was a function. Horizontal line test tells us, does it have a one-to-one function? So first one will. The second one, that's our quadratic formula or quadratic equation or function. It crosses twice. Okay, we saw that with the plus or minus. So this is not going to have an inverse. Looking at the third, we cross 3 times. So that's a no. And looking at our fourth one, that's kind of like a cubic function, some type of odd function. So this is a yes. All right, so now we're going to look at the graphs of our functions and inverse functions. So there is a relationship between the graph of a one-to-one function and its inverse. Okay, it reflects across the line y equals x. And the easiest thing to do is that we're going to change the ordered pairs. So remember, our second step is that we change x and y. Okay, it's the same idea. So now our ordered pair xy is going to change to be yx. Okay, so that's what this picture on the right is showing. So use the graph of f to draw the inverse function. Okay, so I'm going to write out our ordered pairs. So from left to right, we have -3, -2. This is our f of x. We have -1, 0, and 4, 2. So if we want to rewrite this, so that way we get our inverse function, we're going to switch our ordered pair. So this first one's going to become -2, -3. The second one will become 0, -1. And the third will become 2, 4. Okay, so now if we graph that, so -2, -3, 0, -1, okay, and 2, 4. Okay. Notice the graph reflects across this line y equals x. They're mirror images. Okay, that's your line of symmetry. All right, so we talked about the fact that we can't find the inverse of a quadratic function. Okay, we can find the inverse if the domain is restricted. So find the inverse of f of x equals x squared minus 1 if x is greater than or equal to 0. So if we were to graph this, just so we can kind of understand what we're talking about, we know that's a quadratic, starting at our origin and shifted down 1. And we can do our dance. Okay. And since its x is greater than or equal to 0, we only care about the right side of the graph. Okay. Well, if we check this passes the vertical line test, it is a function. If we check the horizontal line test, it passes. We have a one-to-one function. So find the inverse. We're going to change f of x to y. So y equals x squared minus 1. Change x and y, so x equals y squared minus 1. Then solve for y. So we're going to add 1 to both sides. X plus 1 equals y squared. And then take the square root of both sides. And here's what changes. So normally we would put a plus or minus here. Okay? But our domain was restricted for when x is greater than or equal to 0. So looking at our graph, that's only looking at our positive values. So instead of plus or minus, we only care about our positive values, which means we don't need to put that symbol there. So y equals the square root of x plus 1. So our f of x equals, or sorry, f inverse of x equals the square root of x plus 1.